What's up, everyone? Hello, hello. I hope you're all doing well. Thank you for tuning in. We're going to talk about unit rate and slope. So here's your key term right here. Unit rate. You guys have already had this key term before. You should know what the unit rate is. And it's a rate in which the second quantity in comparison to the ratio is 1 unit. So again, we're talking about miles per 1 hour, dollars per 1 gallon, price, cost per 1 ounce, and so on and so forth. So what we're going to do is we are going to interpret the unit rate as a slope as well. So we're going to combine unit rate with slope. So here's our first example that we're going to kind of walk through together and see what we're talking about here. So every 3 seconds, 4 cubic feet of water pass over a dam. Draw and graph situation, find the right unit rate for this proportional, find the unit rate for this proportional relationship. Where here's already the graph. We already have this graph. Okay. So it's every 3 seconds, 4 cubic feet. So 3 seconds, 4 cubic feet. 3 seconds, 4 cubic feet. 3 seconds, 4 cubic feet. Well, the graph goes by 2s. So what I can do is I can also double that rate to 6 seconds and 8 cubic feet. And it looks like that's what we did here. Okay, because this would be going over 6 seconds and up 8 feet. So that's the slope I can use. Since my graph goes by 2, it's hard to use 3 and 4. Now what I can do is I can make a table if I want to. I know I already have the graph. So let's say I didn't have the graph. If I wanted to know what my points were, I can make a table and continue this rate of change, so, or this slope. So 3 seconds is 4 feet. So I also know then that 6 seconds is 8 feet. And I can keep counting by 3s if I want to. This would be 12, 15, which means I'm also counting by 4s. 12, 16, and 20. And this maintains the ratio of 3 to 4. I could simplify all of these and still get to 3 over 4. I can multiply this and get to every single one of these. So I would then graph all of these on a coordinate plane, and then I would find my slope from here. So if we look here, I already have my 2 perfect points, and I already have the work done for the slope. My slope is always rise over run. My rise is 8, my run is 6. Well, if I set it up as a rise of 8 and a run of 6, it does simplify to 4 over 3. So that was that rate of change that we had here, 4 feet per 3 seconds. Now, if I wanted to find my unit rate, what I could do is I would actually simplify 4 over 3. And I would do that by doing 4 divided by 3. Because that would tell me how many feet per 1 second. Because a unit rate, we always want a denominator of 1. So I could do my 4 divided by 3. When I do 4 divided by 3, you get 1 1/3, or also known as 1.3 repeating. And that would be per 1 second. Okay. 1.3 repeating is also equivalent to 4/3. So it's really 4/3 over 1 second. So what's happening is this slope is also my unit rate. My unit rate is 4/3 feet per 1 second. Okay? Or it would be 1.3 feet per 1 second. And both of these would work. But because this is a proportional relationship, and here's the big point here, because this is a straight line that goes to the origin, this is a proportional relationship, your unit rate and your slope are actually the exact same thing. Your unit rate and your slope are the same thing. So this 4 feet per 3 seconds was my slope, and it ended up being my unit rate as well, but the unit rate's a little bit different. The unit rate was 4/3, and we wrote this as 4 over 3. This is the rate of change. But because it's 4 cubic feet per 3 seconds, to find the unit rate, we have to know how much it is per 1 second, but it's still going to stay as 4/3. Okay, it's kind of a weird process to get there, but when I do 4 divided by 3 to find my unit rate, I do get 1.3, which is equivalent to 4/3. So this would be my unit rate, this would be my unit rate, and then this is still my slope and also my rate of change. So they're all very, very, very similar. But the unit rate and the slope are the same when it's a proportional relationship. Now, if I had a straight line, let's say that was going up here, this would not, the unit rate for this line would not be the same as the slope. Only works for proportional relationships. Okay. So now, looking at another example here, I have the equation y equals 2.75x represents the rate in barrels per hour. So I have the amount of barrels, I have hours. Okay. That oil is pumped from well A. So that's for well A is 2.75x. But well B is represented by this graph right here. So I want to know who's pumping oil faster. So there's multiple ways to do this. Okay, but because we know that a proportional relationship, the slope is also the unit rate, for well A, I have the equation y equals 2.75x. But knowing that x is hours, and we know that y is barrels, knowing this information, that means that this well is pumping, this is my unit rate, because this is a proportional relationship. So for well A, the slope is 2.75, which means the unit rate is 2.75 barrels per 1 hour. That's my unit rate because that was the slope. And think of it like this. If I were to plug in 1 hour here into my equation, if I were to plug in the number 1, 2.75 times 1 is equal to 2.75 barrels, which is what will give me my y, which will give me my total. So that's the unit rate. So now we know how fast it's pumping. What I need to do is I need to compare this graph and figure out how fast it is pumping with this one. So I need to find a perfect point and find my unit rate. So looking here, this is my perfect point. And this is when x is 4, because this is counting by 2's, and my y is 10. So it's 10 over 4. And then I would actually need to simplify that and find my unit rate. 10 divided by 4 is 2.5. So this would be 2.5 barrels per 1 hour. So the equation for this particular line is y equals 2.5x. Now I have all the information I need to compare them. Well A is pumping out oil faster. It's giving us 2.75 barrels per hour, or well B is giving us 2.5 barrels per hour. So this one's pumping out just a little bit more oil per 1 hour. That's by looking at the unit rates. I also could have made a table if I wanted to, and I could have graphed this, and this graph right here would be just slightly steeper than the other graph. And I could have made my table by just picking x values. So because I have 2, 4, 6, 8, 10, because I'm counting by 2's, I would have created my xy table for my points. And I would have used the points 2, 4, 6, and let's go 8. And then now what I could have done, this is just another way to do it, is then I have my equation that I was already given. So then I could plug in 2 for x and actually do 2.75 times 2 and figure out how much oil would have pumped out in 2 hours, which would have been 5.5. There's a point. There's an x, there's a y. I would have gone to 5.5. I would have done the same thing for 4. So same thing for 6 and same thing for 8. And that would give me my points. That would give me my graph. That would be a nice and straight line, unlike this one. That is a little bit faster than well B. So by graphing, I could also tell which one's pumping faster by the steepness of the line. And then I could have checked the slopes if I wanted to. And the slope again would have been 2.75 over 1. Or we could have converted that to a fraction by actually counting my rise and my run. Okay. Let's look at another one. This one's nice, a little bit bigger, so it's easier for us to read here. So Thomas rides his bike at a steady rate of 2 miles every 10 minutes. Graph the situation, find the unit rate of this proportional relationship. So 2 miles every 10 minutes. So let's create a table then, okay? Because I know minutes are my x values, miles are my y values. So x and y, I know he went 2 miles every 10 minutes. Whoops, backwards. Whew. So it went 2 miles, and it was in 10 minutes. Okay, so now let's just figure out here. So 2 miles every 10 minutes, graph situation, find the unit rate. But if we look at my graph here, it only goes to 10, right? So my 2 miles every 10 minutes, that'd be 2 miles, 10 minutes right here. There's not a lot of points I can make here, right? I could divide by 2, maybe go 5 minutes. That means he went 1 mile, right? And that'd be right here. And then everything else is going to be an in-between point. Now, I could graph in between points. That's fine. But it's not going to really help my graph here. I know after 0 miles, he went 0 minutes. That is a straight line. So there's my graph. Okay. Now, let's find the unit rate. I want to know how fast he goes per 1 minute. So again, we could find the slope, or we can pick a point. It doesn't matter because they're the same. So I know this point is x is 5, y is 1. So we do y divided by x to find my unit rate. Or really, if we look at this, this went up 1 over 5. 1, 2, 3, 4, 5. So again, my rise was 1, my run was 5. Rise over run is 1 over 5. So my unit rate is 1/5. That means he goes 1/5 of a mile per 1 minute. 1/5 of a mile per 1 minute, because that's my slope, which means that's my unit rate. 1/5 of a mile is 0.2. So you could have also written it like so. 0.2 miles per 1 minute. These represent the same thing. Had I done 1 divided by 5, that gives you 0.2. So that's why my unit rate, or my slope, is equivalent to my unit rate. So then my equation, y equals 1/5 x. Or y equals 0.2 x. Okay? So you guys, this is kind of just combining a bunch of different stuff that we've done already. The big thing to remember here is unit rate is the same thing as slope, if it's proportional. Okay, so that's the big one. Unit rate is the same thing as slope if it is proportional. If it's not proportional, it does not work. And that's it. I hope this video helped. Hope I didn't confuse you guys too much. Let me know if you guys have any questions, and thanks for watching. Gordius out.